Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. Listeners, do you know the modus tollens form of prepositional logic? It has the format if A, then B, not B, thus not A. For example, if the burner is on, the stove will be hot. The stove is not hot, therefore the burner is not on. I got another one for you. This one's a little subjective, but I conjecture if you are a programmer, you're using a large language model in your work. If you don't use a large language model for programming, odds are you are not a programmer. For those that aren't, let me tell you, it is startling how good these systems are at writing code. Not everything, but to just give you an example, half the time what I do is copy and paste my code that I'm working on into it and say, here's my code. Copy and paste a traceroute exception I got and type in all caps, fix. And that's enough. I'm not even sure if all caps is required. It certainly doesn't replace me. If anything, it just makes a lot of stuff faster that I otherwise would have to Google that thing I only do every 6 months. But with how major a tool these systems are for programming, despite being designed for natural language, it's high time we had some good analysis of questions like, what is the best language? That is to say, if we test ChatGPT and its abilities to program in multiple languages. Our null hypothesis would be that the language does not matter. The alternative hypothesis is that there's perhaps some sort of gradient where it's better at some and worse at others. We'll get a more definitive answer to that during today's interview.
I'm Alessio Buscemi. I am currently a software engineer at Lifeware, which is a fintech company based in Switzerland, Luxembourg, and a bunch of other countries in Europe. And I've joined the company just 7 months ago. And before, I was a post-doctoral researcher at the University of Luxembourg, where I also did my PhD, which, by the way, it's nothing related to fintech, but it was more related to automotive. In fact, I was working on reverse engineering the canvas, which is the network inside cars that connects all the electronic control units.
Well, to hear that you're in fintech and have this diverse background also working on a platform I hadn't even heard of till just now makes me kind of surprised that also you have an interest in programming languages and ChatGPT and these sorts of things. How does it all connect for you?
Well, I am always been interested in artificial intelligence because I really see the potential here. But of course, I'm not the only one, clearly. And for my PhD work, mostly, I also had to deal with it. So even if it was, let's say, not strictly necessary for my research, I managed to implement some tools that could help me with the reverse engineering, which makes use of machine learning models such as SVM and simple neural networks that help me identify some partners in the data, indeed, that is shared in this bus. And now that I moved to a software engineer position, I am definitely interested in understanding how these large language models will affect my job. I mean, I'm just starting a career in software engineering, so programming. So it's very important for me to understand the direction of the whole sector. Eventually, upgrade my competencies.
Well, where does your personal journey with programming begin?
I studied in the University of Roma Tre in Italy, where I'm originally from, software engineering. So then I continued with a master at the same university, even though I had some international experiences in Paris, Luxembourg, and also the University of Canberra in Australia. So yeah, I I basically started with the university. I was not a tech guy before, so not the type that would program at 10 years old. So I discovered my passion for programming and IT words at the university, which is, I would say, maybe not a common story.
And do you have an affinity for any languages in particular?
Given that I am kind of oriented towards data science, of course, I like Python. And at the moment, my company, I'm also programming in Smalltalk, which is a very object oriented language, which at the moment is not very popular, but it was prominent language, let's say in the 70s and 80s. And then for some reason, it's not being used anymore. But I find it quite fascinating because it's actually very simple and very clean in the syntax, and also very high level. So it seems to me like a good language. And during my academic studies, I also encountered many other languages such as Java, JavaScript, C, C++, C Sharp, and so on. I don't master most of them at the moment because I really haven't used them, but I have a basis in many of them.
Sure, I don't think anyone mastered every programming language, or if they did, like that was the point of it, and that's what they do now. There's just so many. Why would you learn all of them? But you've learned at least a couple and been exposed to many others. You probably know about Turing completeness, that basically any programming language that can do the not and operation can do anything. But, aside from that, do you have any thoughts on the invariance of languages or why you pick one over another?
So for me, again, it's mostly related to the domain. So what serves the best my purpose? For instance, this I could see a lot in the automotive sector, where I conducted my research. Given that we are dealing with hardware, then of course you would mostly use lower level languages, which are also less computationally require less computational resources. But of course, then all these languages that are more for data analysis, such as Python, R, etc. They are not computationally efficient, but they do the work because they can rely on very big and use and updated libraries. So for me, I really don't have specific preferences, but I would rather like to use more the languages for which there is more support from the community, let's say, which is not the case for small talk, as you can imagine. But I get very strong support from my colleagues, which has specialized in the last 20 years on it. So I still feel that it really serves the purpose of what I'm doing right now.
Well, I suspect most listeners will already know that ChatGPT and other large language models are definitely capable of writing code. They write syntactically correct code. Maybe it's not perfect every time, but when they spit it out, it's often useful. You can definitely generate code with the large language model. Not everything, but some things. Now, you're a recent graduate, and in your role as a software engineer, you're bringing a lot of skills to the table, but a very important one is your programming. A big part of your output is the code you write. That's not all you do professionally, but that's a big part of it. Did you at any point feel a little bit threatened by the emergence of LLMs?
I don't feel especially threatened in the short, medium term. As experimented with ChatGPT, I definitely found out that its capabilities cannot at the moment substitute the work of a software engineer. As I would say, it has more or less the capabilities of an undergrad student. But of course, this does not prevent it from improving over time, which of course will happen. Where others see threats, I also see an opportunity because, of course, it can make my job easier as long as I have control of the tool. So, for what I see, but it's not only my opinion, the job of software engineers will definitely change in the future, meaning that we will probably have to write less basic codes, let's say code snippets that are trivial. Perhaps they do basic and repetitive routines, but they still need nonetheless to be written. This we can delegate to these large language models, and maybe we connect the dots, meaning that we shift our role more towards an architectural figure, meaning that we understand better at a high level the system, and we are able to connect more these code snippets that have been written very fast and I hope correctly by the models. So this is how I see it. And if this is the case, just see as a tool to increase my productivity and not necessarily to replace me as a software engineer at 360 degrees. So this is my hope. This is understanding of the future. I know that there is this general fear at the moment, and I guess you are closer to the heart of things, given that you are in California. But no, to summarize, I don't see a threat. I see an opportunity, and for sure, I will keep a close eye on it because for sure I will need to upgrade my skills soon. And I'm already looking into ways of improving my productivity thanks to these models.
Well, there's a phrase I've heard tossed around a lot by people commenting on how these models can be useful to programmers kind of supplementally. And they say, oh, this can make you a 10x engineer, as though what you used to do in 1 hour, you could now accomplish 10 hours worth of work in 1 hour. If you're using it, you must be, making an improvement. You wouldn't do an hour's work in 2 hours if it was inefficient. It must add efficiency. But is 10x the right number in your personal experience? Thanks to our newest sponsor, math.fashion. Yes, that is a real URL. Visit math.fashion and check out their line of mathematics themed t shirts. They sent me the Klein Bottle shirt, which is pretty stylish. I've gotten a few compliments about it, and each one is the opportunity to start a long conversation about two-dimensional manifolds. Get more math in your life, specifically on your body. Visit math.fashion. Is 10x the right number in your personal experience?
Oh no, for the use I make right now, definitely not. But we are just at the beginning, so who knows where this goes. I would say for now, I make little use of it, but for sure, we can expect to maybe instead of writing just simple code snippets for a single task, we can maybe one day just say, can you please write me the interface for this website, which these characteristics, and it will write thousands of lines of code at once. But to me, the very important part is again control. You need to understand what it does. You need to be able to interpret the code that it writes, also to spot bugs and vulnerabilities. So this is where the knowledge of and the expertise of a software engineer will become relevant if, of course, it allows us to achieve a 10x improvement on productivity.
Well, we could share anecdotes back and forth about a situation where we tried it and it worked well or didn't work well, but it's much better to have actual data. So that's why I was really glad to find your paper, A Comparative Study of Code Generation Using ChatGPT 3.5 Across 10 Programming Languages. Before we dive right into the results, could you just describe a little bit about the setup and what you were trying to accomplish in this?
After trying a little bit ChatGPT on Python, Smalltalk, and other languages that I have at least a basic knowledge, I noticed that for the same task, it performs better on languages that are definitely more popular, which kind of was expected because, of course, the quality of the output it's mostly due to the base on which the model has been fed on the training set. So we can fairly assume, but also this is been proven by certain statements released by OpenAPI and in general the large language models community, that the corpora on which these models have been trained kind of reflects what is the current software situation. So of course they have been trained more on more data or more code from popular languages compared to others that are not so used. So we can expect in general better performance. But the real question here is, which is the starting point of my research, are there languages that are more intrinsically fit for code generation through LLMs? And so I conducted this study to see whether indeed there were maybe some not so popular languages that could perform as good as the popular ones, as well as maybe trying to find some patterns that could identify what are the characteristics of a language that make it more suitable for code generation. I selected 10 languages, which are C, C++, Go, JavaScript, Julia, Perl, Python, R, Ruby, and Smalltalk, of course. And I asked ChatGPT 3.5, and just to be more specific, the turbo version that is available through the OpenAI API. I fed 40 tasks in 4 different domains, which are basic algorithms, which are simple problems at undergrad level, games, so popular games, video games, data science, so for instance, to implement known machine learning algorithms, and security, some security tasks. So 40 tasks in total, 10 for each of this category across all these 10 languages to generate, again, code to address these challenges. I found many unexpected results, which I would like to dig into with you a little bit because I find it exciting, partly worrying, but for sure surprising.
Unexpected is one of my favorite areas to dive deep into, and I do want to get there, but right before we do, could you maybe share an example of one of the tasks just to set some context for, like, what do you prompt the LLM with and what's the challenge?
All right, so for the simple algorithms category, for instance, I have it here. Check whether an integer is a palindrome or not. So, very basic. Or for the data science domain, implement the algorithm for random forest. Again, there are multiple ways of doing that. And my approach to this was also to investigate the creativity of ChatGPT. So I kept most of these challenges as vague as possible, also to try to understand whether its understanding of the task depends on the chosen language. Another task, just to clarify what I'm saying, is implement a simple version of the game Pong, which we all know. What does this mean? Does it mean that you allow one player to play against the computer? You allow two players to play together? You simulate the game somehow? To what extent, if we are playing against the computer, are its capabilities? So this task is very vague on purpose. And I really wanted to see how its interpretation would vary according to the different languages. Indeed, the results confirm that my question was well formulated because we have some weird behavior here.
Well, I like the idea of the vagueness of it. Generate a game of Pong. And if instead it spits out a formula for interest calculation, we can say, indeed, that's not Pong. But what is Pong? There's kind of a fuzzy line. How do you actually decide if the output meets the request?
My analysis of the output was just made on whether, first of all, if the model would output any code, because in many instances it just refused to output any code, either for ethical reasons, which is also interesting, or for just manifest incapability of solving the task. And if the model outputs any code, then whether this code can be compiled in the case of compiled languages such as C and C++, and if it's compiled, whether it can be executed. In some instances, it was not possible to evaluate whether the execution failed or not because it just the behavior was too apparently weird. And I, given that I run 4,000 tests, I could not qualitatively assess with my time whether the execution was correct. But indeed, if there was a clear output, then I would judge the execution as successful. The next step, which would be interesting to investigate, it's indeed from a semantic point of view, if it would do all the things that we would expect. But again, this really requires a human benchmark, I assume. So I left it for future work.
Well, there's a sort of natural hypothesis here. You kind of implied earlier that maybe the volume of examples on the internet is highly correlated with how well the LLM works. The amount of Python examples you can find on Google is probably 10,000 to 1 the examples of small talk you can find. Does the ability of an LLM to generate code does it highly correlate with the availability of examples?
This is a fair assumption to make, and I think also the magnitude it's somewhere near what you just said, so probably 10,000 to 1. I would say, based on the results, that we don't see this be reflected proportionally across the different languages because, yes, of course, as expected, Python performs the language performs better in Python compared to Smalltalk. But also, it's not too bad in Smalltalk. So it would be interesting now to know if we would train on a similar training set on Smalltalk, would it perform still lower, as good, or even better than Python? This, I think, requires effort, but also is a very fundamental question that needs to be addressed to understand the future of the whole programming world. So, what I could see is that apart from these languages, such as C, that are lower level, in general, it performs worse. And I would say it's also fair to assume that it has seen more samples from C rather than Smalltalk. And still, it performs definitely better on Smalltalk compared to C. So this should give us really a hint regarding the characteristics of language, of the suitability of a language for code generation. My understanding, but also this is the understanding of many other researchers, is that lower languages increase the complexity of understanding for the LLM, because of course you don't have, for instance, the garbage collector and other nice automated tools, and this increases the complexity for LLMs, that it's more prone to write buggy code. So for sure, we can say that these models will increasingly perform better on higher level languages, and probably we will see a further shift towards these languages. So my understanding is that based on the efficiency of these large language models, which is something that I also investigate in the paper, we will see certain trends in the industry. Certain languages which are more suited will likely be more popular, and some others will be gradually abandoned. But again, we may even see, this is my prediction, we may see even languages that are born literally just to be optimized for code generation. So who knows? Maybe we will see emergence of new languages that don't exist today.
Well, let's get back to those 40 tasks you had mentioned, the challenge you were going to put to the test. Could you share some of the details on the results and how the various languages performed?
As I mentioned, we see that Python is the one that performs the best with Julia, which surprisingly, if we ask even to ChatGPT itself, is not on the top 10 languages it has been trained on, but still it performs quite well. So maybe Julia is well fit for code generation. And then it performs also pretty well on JavaScript and Ruby and R. And then we have Smalltalk, Go, C++, and C in order. I forgot also Perl, which is also where it also performs fairly good. On the domain level, we can see, as expected, the easiest tasks were those in the algorithms domain. So algorithms that deals with numbers and operations on strings, follow but not consistently by data science tasks, security, and games. Again, not consistently, which means that in some languages, for instance, in Julia, actually the data science by a l- small margin is even better than the algorithms. For instance, in Perl, data science is the results on the data science tasks are way below those in the algorithms. It seems that, yeah, games were the hardest to address, and I also understand why, because it would probably require bigger code snippets, probably some more structuring in terms of classes for object oriented languages, because the task itself was for sure more complex. So this is what we could see. I don't have the arrogance to say that, of course, this study proves much, because again, these tasks were highly arbitrary, but for sure can point in certain directions. And more than the actual results, which again gives us some nice feedback on what are the privileged languages and what are the domains that are considered to be more suited for code generation. What I think is very valuable here are the exceptions and all the, if I may say, even crazy behavior that I experienced by analyzing the output of ChatGPT.
Well, I was pretty surprised to see Julia at the top of your list. It's a relatively young language. I understand it has a great community, but it's not necessarily the most popular language in the world. Certainly, it doesn't have the most examples on the internet. So it goes against the theory that this correlates with volume of examples. Do you have any idea why Julia performed the best?
Honestly, I'm sorry, but I don't. But no, for sure, it's very valuable to know that Julia performs even slightly better than Python, which again should really raise a lot of questions in the industry, in the academic world, of course, but most important in the industry that in the end sets the trends. It should really raise the question of, well, are we giving a fair assessment of what are the best languages for code generation through LLMs? If we find out that, for instance, based on the same volume of code snippets, ChatGPT would perform so much better on Julia compared to Python. Then this has very disruptive potential in the industry, because then companies would consciously decide to shift towards Julia, for instance. The communities that are contributing to this language would then definitely thrive. I don't think at the moment we are giving it a fair evaluation, because it's really unfair to feed these models with huge volumes for certain language compared to others, and we really don't have the a fair benchmark on which base consciously our business decisions. At the moment, what's happening in the industry in most cases is that you would choose a language also based on the support in terms of open source community, as well as IDE that support the language, etc. If we assume that LLMs are gonna be a structural part of our job in the future, then of course this will be really twisted, and we need answers, and we need them as soon as possible. And to have these answers, we need to have a fair benchmark. So I really ask the research community and the industry to investigate this as soon and as possible and at a scale.
Well, if you had had slightly different results than what we described, let's say one of these languages, maybe it's Smalltalk, had performed 30% better on every single task, that might be a good reason for companies to think, hey, let's move everything to Smalltalk. For the results you actually did get, could you comment on sort of the magnitude of the difference? Are we arguing over pennies, or is there a really significant difference here?
Thanks for the question. Actually, I gave it for granted, but no, your question is very compelling, because I didn't give the magnitude of the difference in the results. No, actually, the languages on which it performs the best have a success rate even close to 80% and exceeding in certain domains. For instance, if we challenge GPT on the 10 algorithms for Python, we reach nearly 100% of correct code being generated. While for the same category in, for instance, Smalltalk, we get only a bit above 20%. So we are talking about huge discrepancies. And just to give another example, in C, we are having only a bit more than 7% of the code being correctly generated, meaning that it runs and it's bug free. So, yeah, no, we see huge differences. But again, are these differences proportional to the volume of the data the model has been trained on these languages, or they are least or more than proportional? And that's really a key question to ask ourselves.
And if, let's say, the advantage shifts and certain languages start making updates, or maybe the LLMs get updated, but for some reason we see the leaders moving ahead, or maybe a new language designed for this purpose gets ahead, would we switch to that language, or would we just find a way to ask the LLM to transpile our language to the better language and then to do the work, or something along those lines?
Wow. Actually, I thought about this and I don't have an answer, but from my personal experience, it's not really good practice to query the model to an optimized language and then ask basically to translate into another one. I don't think it's a very optimized way of working, and the more steps you add, the more prone you are to bugs. For legacy reasons, I can imagine that some companies would actually do that, at least in a first place, because of course you cannot replace code base that are 20 years old from today to tomorrow, right? It cannot happen overnight. I assume some companies may even try to do that. For my personal opinion, I don't think that's a very wise approach, and it's not a sustainable approach. So if I was the CTO of a company, I would definitely push for adopting the optimized language as soon as possible, maybe starting with a smaller experimental project and then gradually shifting towards it entirely if possible. I know that in most cases is not possible because of legacy, but yeah, if you want to innovate, you cannot keep adding layers just for the sake of preserving your legacy.
Well, you'd mentioned earlier that there were some unexpected results. I think we touched on some of them. Did we touch on everything unexpected?
Another example, the task I also asked to produce a very blunt brute force attack against passwords and username with 100 combinations, which of course in the real world does not mean anything. But for computational reasons, I couldn't ask to brute force with millions of combinations, of course. What is interesting is that it's seen unethical across all trials, all instances when executed, when asked to execute in JavaScript, but conversely was rated ethical in 9 out of 10 instances when implemented in Go, and 8 out of 10 when executed in Julia. So, how does the choice of the programming language affects the unethical assessments of ChatGPT? To me, if the model really understands what it is being asked, what is the actual task from a semantical point of view, then the ethical assessment should be the same for all languages. Instead, what is my understanding is that based on the data sets it has been trained on, and maybe even the comments within these data sets, is ethical assessment changes. So it actually retrieves the motivation behind his assessment in the code itself. Because again, otherwise we wouldn't see this. This is, for me, a fair assumption to make. And these results are very puzzling and very worrying, because it means that in the end, this model doesn't really have any understanding of what's ethical or not, despite all the efforts of OpenAI, which again, it's being very debated. And as you know, they are trying to tweak the model in such a way not to be racist, not to provide answers that are against common sense and common decency. But again, it seems that when tackling code tasks, then the ethical framework falls apart. And this is really dangerous, especially with respect to security.
Well, my personal experience with programming languages, the first one you learn is maybe the hardest, and you kind of think in that dialect, but over time, as you learn others, there are parts of it that become universal. And I could pick up a new language and be using it productively probably in one day, although it would take me a little time to kind of do things in the structure of that language. I would, like, if I started doing small talk, I would be like a Java engineer bringing my Java ideas and then have to adjust and kind of localize myself. but underneath it all, there's sort of like a core, not to sound arrogant, but I could program in any language if I have a little bit of time to learn it.
Sure.
Do you think that's happening in the LLM as well, or is it really kind of on different paths?
Difficult to say because it would mean that it has the same learning patterns as humans, and I don't think that's the case. I think there are profound differences in the way these models work and how a human would actually learn. So I think that my answer would be no. It learns each language is in a completely unique and probably for us not possible to understand way.
And as we talked about, this was all done with ChatGPT 3.5 Turbo. New things will become available. I guess you could use Lambda 2 if you wanted to, but certainly fast forward a year or two, there's going to be new models available. What do you think is going to happen if you were to repeat the process on something bigger and badder?
So, as we all know, we have already ChatGPT out there. ChatGPT 4 out there, and someone is already talking about 5, but I don't think is in the actual works of OpenAI, or maybe we will see release next year. For instance, ChatGPT 4 works so much better already compared to 3.5, so it would be interesting to repeat this whole process with the new version of ChatGPT, and also maybe open source models such as Llama that you mentioned. Actually, there is also another one that seems quite promising, Mistral, from a French startup. And I would be also interested in trying that. So yeah, for sure, seems like a nice investigation path. At the moment, I can already spoiler you that I am going in another direction. I'm working more on sentiment analysis. I'm already comparing these different languages on the same tasks because I wanted also to investigate a different domain. We'll let you know the results when I have them. But yeah, no, I mean, for sure, I will repeat these tests, maybe for my own sake. I don't know if the scientific community is as interested, but for sure, for my own curiosity, I will do to a certain extent this comparison. So who knows? Let's see. Maybe I will also publish another paper about that.
You'd mentioned the sentiment analysis investigation. Is there anything else you're working on or things you'd like to share about where you're going next?
Well, of course, I cannot release due to privacy reasons current projects with my company. Also, because we work in a very sensitive sector, which is the sector of life insurance. So I cannot talk about that. But again, I spoiled you my side personal project, which is on sentiment analysis. And also, I would be interested in investigating plagiarism. So I think I will also make one or two experiments about that because, as we know, this is also a big issue currently. Students are using it to cheat on exams at any level of education from high school to college. So, yeah, I think it's very relevant as well. And I would also like to investigate how the different models performs to have an idea of which one is better at this task. And that would include, for instance, tools also like Quillbot, which is quite popular. It's also for me very interesting because plagiarism is another area of the natural human language that requires a deep understanding of the context, of course. So to me, it's another area where rephrasing shows, because in the end, sorry, I give it for granted, but what I meant is by rephrasing, rewriting a certain text, then of course you are prone to plagiarism. So what I wanted to say is that rewriting a text, rephrasing a text also shows a deep understanding of the context of the text. I'm not a linguist, so this is my understanding from my programmer point of view. So yeah, I also find this area quite interesting. So I will follow more or less the same approach, and if I go in this direction, as I think in the next months, I will also let you know, and I will also publish a paper, and you will be one of the first people to know.
Well, looking forward to that. And is there anywhere listeners can follow you online?
On LinkedIn, I would say, Alessio Buscemi, you will find me. And apart from that, unfortunately, I'm not on Twitter. So yeah, I would say follow me on LinkedIn.
Sounds good. We'll have a link in the show notes for listeners to follow up. Thanks you so much for taking the time to come on and share your work.
Thank you very much for hosting me, and have a great day.
You too.